Whiplash is a common injury that occurs when the neck is forcefully jerked back and forth, typically caused by rear-end collisions. It can have a significant impact on a person's quality of life, with symptoms including but not limited to chronic pain, neck stiffness, and even paralysis. About 3 million Americans sustain whiplash injuries each year, and around half that number suffer chronic pain after the injury. It's especially difficult to deal with because symptoms can take as much as a few hours to a few weeks to arise, at which point it's too late to reverse chronic conditions. There are a few technologies currently in place to deal with this issue, such as the Toyota Active Headrest and iPhone's Call After Severe Crash, but these technologies don't actually detect whiplash. It's essential to find a solution to delayed diagnoses that can significantly increase the chances of long-term complications. That's why we've developed a sensor that can help detect and prevent potential whiplash injuries. Beyond personal use, we built this device specifically with industrial customers in mind. By analyzing the data collected from these sensors, engineers can enhance vehicle design and safety features, reducing the occurrence and severity of whiplash in their cars. Understanding the mechanisms behind these injuries leads to innovative solutions that prioritize user protection and advance road safety.
Our solution to the whiplash detection problem is a wearable sensor that we call NeckTech. The sensor is strapped around your head and contains a dual gyroscope and accelerometer, which measures changes in linear and rotational acceleration. If the sensor detects a large force from its position on the top of the user's head, it will immediately text emergency services, allowing the user to get immediate treatment. The sensor is cost-effective, easy to wear, and does not require any interference after initial setup, making it an efficient device for practical applications.
Our workflow starts with turning on our Arduino. When the Arduino turns on, it takes acceleration and gyroscopic readings every 500 milliseconds and sends a request to our Flask server, which has to then determine whether the readings constitute whiplash or not. To detect whiplash, we built a dataset of readings that correspond to known whiplash cases, and train a machine learning model that distinguishes between normal head movement and possible occurrences of whiplash. Once this model predicts whether or not the readings constitute whiplash, data is uploaded to our Firebase real-time database, which our website will access to create acceleration graphs that you'll see in a bit. Users are also contacted about their whiplash injuries through the Twilio messaging API. Through a Twilio-generated number, the user is sent a text message detailing when and where they have been injured. In a real whiplash case, we would replace the user with the appropriate contact information of emergency services, giving them full details about the location of the injury.
The device is composed of a few components. You can see 3 knit elastic straps, one around the head, one around the chest, and one additional strap for stability on the head. You can see the 3D printed containers that these straps are threaded into, with foam underneath the large box for comfortability. The small container has our sensor, while the large container has both our Arduino Uno and battery pack. The lid of this container slides in and has appropriate holes for wires so that users can still take them in and out. Here's the circuit being built. You can see the lights turn on when the circuit is done.
Now let's take a look at our website, where we provide comprehensive information about whiplash and our sensor solution. On the homepage, we highlight the mission of our team in creating this device and making it available to the public. Underneath that section, we also talk about each team member's individual contribution to the project. Then, in the Our Project page, we elaborate on the dangers of whiplash and the importance of prevention, aiming to educate users about the risks and encourage them to take proactive measures. We also describe how our sensor works on a basic level. In the Procedure page, we outline the steps to use our sensor, which we will demonstrate soon. Next, we're going to look at the user dashboard. First, we must sign into our account. Then we will be automatically redirected to the dashboard. Here, users can view graphs of their head's acceleration and gyroscopic values, which will be used to determine if the user is injured. As these two graphs are loaded, they will highlight dangerous data points in red as seen here. To change data collection sessions, there's a calendar that allows you to pick between active sessions and a drop-down menu for each session from that day. When a new session is picked, the graphs are updated and new data is loaded.
Now, how do we use the sensor? The first strap goes around the user's chest, right underneath the armpits. The second strap secures the device to the user's head. It should be placed around the forehead. When the device is worn properly, the sensor should be at the top of your head like this. As you can see, the device is secure on the user's head. Now we're going to open the dashboard so we can begin data collection. The sensor just started recording data for the session when I logged in, so we can now see the data entering Firebase live. Now let's simulate a sudden head jerk to show whiplash. When we refresh, we can see that the date and time automatically update to match the most recent session. So you can see when I'm just sitting normally, as I would when driving normally, the model did not detect any instance of whiplash. When my head jerked as before, there's a big spike with the highlighted data points. These red data points were highlighted based on the machine learning model described earlier. I've also received text messages warning me about the earlier whiplash incident.
Our sensor technology presents an effective solution to address the dangers of whiplash. Users can benefit from real-time monitoring and alerts provided by our sensor. We hope that by spreading awareness and providing preventative measures, we can contribute to reducing the incidence of whiplash injuries and creating a risk-free world. Thank you for listening to our presentation.